Hey guys, sorry I'm gone again today, but hopefully the Kahoot worked today and you have a little bit better idea of recursive sequences, what they look like, how they're used. So we're going to kind of move on into 1.2, which is modeling growth and decay with these same recursive sequences. Alright, so growth and decay, this is your real life scenario stuff. This is depreciation, this is interest. That's where all this stuff kind of comes together into where do I use this in real life. Alright, so for example, so an automobile depreciates or loses its value as it gets older. So the second you drive your car off the lot, it is now worth less than what it was that you paid for it. So, and where this is used a lot, especially in farming when it comes to taxes, depreciating buildings, depreciating machinery, that kind of stuff. So this is one example. So suppose that a particular automobile loses 1/5 of its value each year. We're going to write a recursive formula to find the new value of this car when it is 6 years old if we paid $23,999 when it was new. Okay, so our recursive formula, okay, so we're defining this for however many years down the road we're going to lose or have this car. Alright, so the year, we need to know what the value is from the year before because it's going to lose value off of the years before value, not at the same, not off of the original value. Alright, so it's losing 1/5. Okay, so if we take this $23,999, okay, and we multiply it by 1/5 or 0.2 as a decimal, okay, we will get how much we're taking off, but how much is it actually worth? So it's actually worth the opposite of this, so 1 minus 0.2, so it's actually worth 80% or 0.8 of our starting value from the year before. So this 0.8 is what's going to go in front of our u sub n minus 1. Okay, so this is going to be our recursive formula. Obviously, we are starting at year 0 when it's brand new, and a cost of $23,999, right? We're starting at year 1. Okay, so we want to find out what the value of it when it's 6 years old. Okay, so this is where our Google Sheets come in handy. All right, so in box 1, I'm going to put $23,999. Okay, that's our starting value. I'm using the same sheet that I used the other day. I'm going to start at year 0. Okay, but my formula this time is going to be, so box B1 times 0.8. Okay, so it's going to change all those values. We're looking at year 6. That's not right. Oh, we got to copy that. That's fine. Okay, so copy that down. We go to year 6. You can see that the value at year 6 is $6,291 and some odd cents. All right, so that's how we use depreciation. All right, an example of growth. So Gloria deposits $2,000 into a bank account and it pays 7% annual interest compounded annually. So what that means is she's getting 7% interest on her $2,000, and then the next year she's getting 7% on her $2,000 plus the interest she gained that first year. Okay, so if she keeps leaving the original amount and the interest in the account, we want to know when that deposit is going to double. Okay, so to write our recursive formula, so u sub n, we have our u sub n minus 1. Okay, so we're starting at $2,000. This would be actually year 0, $2,000. And it's growing at 7%. Okay, so if we multiply this u sub n minus 1 times 0.07, that's going to give us our interest. Remember, we want the interest plus the amount that was in there to begin with. So that's where this 1 comes into play, so 1.07. Okay, we're starting at year 0, so our n is greater than or equal to 1. If we go back to our spreadsheet, okay, we can go ahead and change some of these numbers. So this time we have a starting value of 2,000. Okay, and we're going to multiply that times our common rate, so 1.07. Okay, and if we go ahead and paste that down, we want to know when it's going to double. And it looks like somewhere between years 10 and 11, she will have double what she started with. All right, so that's an example of growth. All right, so here's some examples of growth and decay. All right, so the temperature of hot chocolate. So when I first get it, it's super hot and it cools down. Okay, so this is going to be an example of decay. Okay, we could measure the temperature as time goes on. All right, the amount of money in the savings account, we just did that one. That one's growth. All right, food left in the locker. If you kept snacks in your locker, if we were allowed to do lockers this year, okay, as time goes on, that amount of food in your locker is going to decrease. Okay, that's an example of decay. If you leave it in there long enough, it will decay. All right, population of a city. Now, to me, this one could go either way. It could fall in either, depending on whether or not your city is growing or losing population. All right, height of a bouncing ball. This was an experiment that we would have done had I been here. All right, as time goes on, the ball's going to bounce less high. That's an example of decay. Value of a car, depreciation. Okay, that's decay. All right, now we're left with these two formulas. All right, so how do we know where they fit? If we look back at the two formulas that we wrote, what we are looking at is this number and this number. All right, if you look at those common rates, remember that's our common rate. This is a geometric sequence for multiplying. Okay, if you notice, this one is 0.8 and that one is 1.07. All right, so if we look at the examples that they give us, we have 0.8 that one, and we have 8 there. All right, so decay is always going to have a common rate that is between 0 and 1. And growth is always going to have a common rate that is larger than 1. All right, so those are some examples of growth and decay. I know that was super fast. Tomorrow when we start class, I will give you time to ask questions on 1.1 and we'll clarify anything with 1.2. So your assignment for 1.2 is numbers 1 through 4. Okay, again, you're at finding the common ratio for each sequence, identifying it, whether it's growth or decay, and then find the percent change. So this was like, here our percent change was 107%. There our percent change was 80%. Okay, so that's what it's asking for those. 2 is actually writing the recursive sequence. 3 is writing a recursive sequence for those 3 scenarios. 4 is matching to the graph. Okay, so we're looking at our common rates in these and determining whether it's growth and decay or staying the same and what that would look like on a graph. Okay, then 8 and 10 are some application problems. So 8 and 10. All right, so that's homework. Again, go ahead and try those today. I will be back tomorrow, hopefully, and we can go over any questions that you have on those.